In this problem, we've got the same rates and the same initial number of penguins, 40,000. And we've been asked to find the maximum and the minimum of the penguin population over the time period 0 to 6. So before, we identified the number of penguins at any time as being equal to the initial starting number of penguins plus the integral from 0 to some time x of bt minus dt, and these are the rates that penguins are born and have died. And so, like any absolute maximum or minimum problem, the only places that we could have the most are the endpoints and any interior critical points where the derivative is 0. So this is where my rate will be equal to 0. Here's another RT equals 0. And these are the endpoints. Okay? So that means if I was to set up a table, I know already that I better check time equals 0 and time equals 6. And so at time equals 0, I would have 40 plus the integral from 0 to 0. Well, that's just going to be 0 of this birth rate minus death rate. So this first answer is 40,000. At 6 years, we're going to have 40 plus the birth rate from 0 to 6 of the birth rate minus the death rate. Well, we found this in part C to be 46,000 penguins. Again, adding this 40 and whatever this number is was in thousands. So that answer was 46,000. The thing that we don't know is where, if anywhere, were the derivatives equal to 0. So were there any interior critical points? That's what these are. So we're looking for the interior critical points. Well, our critical points are always where our derivative equals 0. So we want the number of penguins, the rate that they're adding and subtracting, that derivative to be equal to 0. So when I take the derivative of both sides of this equation, the derivative of any constant is 0, so the 40 part is going to go to 0, plus the derivative is going to cancel out the integral, and I'm just going to have the birth rate minus the death rate. So that needs to equal 0. So the birth rate minus the death rate equals to 0 is really what you see right here, the birth rate minus the death rate. Well, when I simplify this, I really have t minus 2 equals 0. Well, that's going to happen at t equals 2. So I know my time. The only thing left to do is to find this integral. So 40 plus now the integral from 0 to 2 of 2t plus 1 minus t plus 3 dt. So 40 plus the integral from 0 to 2 of t minus 2 will be equal to 40 plus the antiderivative of t, or t squared over 2, minus 2t from 0 to 2, or 40 plus 2 squared over 2 minus 2 times 2 minus 0 squared over 2 minus 2 times 0, that's just 0. Well, this will be 40 plus 2 squared is 4, divided by 2 is 2, minus 4, or 38. And again, all of these are in thousands of penguins. So at that interior critical point, we had 38,000 penguins. The absolute max number of penguins was that 46,000. And it turns out that it was at t equals 6, one of the endpoints, but the answer is 46,000. The absolute minimum was 38,000. That was at t equals 2, which was an interior critical point where the rate, the combined rate of birth and death, was equal to 0. Two answers to answer what was asked for: 46,000 for the absolute max, 38,000 for the absolute minimum.